Hi guys, in this video we're going to look at where AC DC get their name from, being the two types of electrical power, alternating current and direct current. We're firstly going to talk about what current is, then what direct current is, then compare that to alternating current and the benefits of alternating current and why we use that in our mains power grid. So firstly, current being the flow of electrons through a circuit. So we've got our little electrons there and you can see that they are flowing around this circuit. And we can actually measure current quantitatively as to how many electrons pass a point in a certain time, but we'll get into that in another video. So direct current is what we just saw before. And it's the electrons flowing from the negative terminal to the positive terminal in a direct fashion. So just from one way to the other way. And the reason that these electrons move around like this, and this is a very simplified animation that I've got here, because every single atom within that circuit would have electrons in it. Okay, that's a conductor. These electrons can move around. So what we do is in the negative terminal, there's a whole heap of electrons there, or a build-up of electrons there trying to get out. And because electrons are all negative and likes repel, those electrons repel each other and push the electrons around them, around the circuit to the positive, which has relatively less electrons there. So the electrons are pushed from the negative and pulled towards the positive. In alternating current, the electrons don't flow around the circuit as much as they sort of jiggle backwards and forwards. So instead of having a positive and negative terminal, we have the terminals what we refer to as passive and active. And what this means is that these terminals are actually changing their polarity. So they're starting as a positive and then switching to a negative, then switching to a positive, then back to a negative. And basically the electrons don't know what to do. So when the terminal is negative, the electrons will move away from it, but when it turns back to positive, they'll be attracted to it again. So they just vibrate backwards and forwards. And in Australia, we use 50 Hertz power, which means that these electrons vibrate backwards and forwards 50 times every second without actually flowing around the whole circuit. So none of these electrons will carry around the whole circuit. They'll just vibrate backwards and forwards in the position that they're in. Now we use AC power in our mains power grid. So when you plug something into a power point, that's AC power. Now the reason we do this, well there's a couple of reasons, but one of the reasons that we do this is it's easier to produce. So running a turbine producing AC power, alternating current, has less moving parts than one that would have to produce direct current. So it's easier to produce. Same, once we get it to our house, it's easier to use, especially with electric motors. Anything that's got an electric motor in it is much easier to power through AC than it is through DC, and there's less moving parts in that because you don't need a commutator. One of the downfalls, and you'll see that these, I've got a washing machine, a fridge and a mixmaster, and these are all old appliances, electric motors, moving parts. Problem with this is that new things such as computers and anything with semiconductors in them require DC or power or direct current. So for example, charging your phone, you need a converter that converts the AC power into DC power to charge your phone, and that's what that big box on the end of your charger is. So it's converting that to that DC power. Another huge benefit of AC power is it's much easier to transport over long distances. As the amount of current or the amount of electrons moving around increases, this decreases the efficiency at which those electrons can move through a wire of a fixed size. So what we can do is we can use what's called a transformer, and this picture here is a picture of a transformer. And what that does is convert the power as it's made at the power plant into super high voltage, talking about thousands of volts, that can then be transported through these high voltage power lines to your house. Then when it gets to your house, you have another transformer that turns it from that high voltage down into the 240 volts that we use in the home. In this video, we've looked at current being the movement of electrons, direct current as being the electrons flowing around the circuit in one direction, alternating current being the electrons jiggling backwards and forwards because the polarity of the terminals is changing at 50 times a second, and talked about some of the benefits of alternating current and why we use it in the home, being that it's easier to produce, easier to use in electric motors, and easier to transport. I also snuck in some of the downfalls of AC there, in that it can't be used with semiconductors. Thanks for watching, guys. Peace out.